Okay, very good morning, everyone. Hope my voice is audible for everyone.
Yes, Akhilesh, it's audible.
Okay,
Good
ma'am.
morning.
Thank you for
Okay.
joining me.
So before we start, should I give me permit me to give a small introduction about
Sure,
about
ma'am.
me?
Sure.
Okay, so should I start?
Sure, ma'am. Sure.
So good morning to one and all present here. I, on the behalf of EC Department JUIT, welcome Mr. Akhilesh Kumar, Assistant Manager, Application Engineer, Design Tech Systems Private Limited. Mr. Akhilesh has over 8 years of experience in industries and education. He has done his MTech in Electronics Design and Technology from NIT, National Institute of Electronics and Information Technology. Mr. Akhilesh has also assisted DRDO, NML, IMMD, MPL, IITs and NITs and other Indian government bodies in various applications based on IoTs, forecasting, data analysis, wireless sensor deployments, hardware interfacing, computer vision models, and many others. And Mr. Akhilesh has good command over MATLAB, Simulink, signal processing, machine learning, deep learning, artificial intelligence, code generation, hardware interfacing, model-based design, data analysis, and data analytics. His research work and application include channel capacity enhancement in wireless communication networks, EMI filter design for mobile communication devices, wireless sensor clustering and deployment to increase lifetime of sensors, and COVID-19 detection based on X-ray images using deep learning, live face mask detector using deep learning, machine learning model to detect diabetic patients, and different kinds of arrhythmia using ECG signals. COVID-19 forecasting using statistical model and machine learning, and IoT-based apps using low-cost hardware. So, he has many publications in his. He has done many publications, and his research publications are published in EMI reduction techniques for mobile communication devices. Then in IEEE also he has publication that is channel capacity enhancement using NEMO technology. Then in Access 2012, he has channel capacity enhancement of wireless channel using MIMO technology. Again in IEEE, he has another paper, signal processing and channel capacity enhancement using MIMO technology. Channel capacity enhancement of wireless communications using MIMO technology is published in International Journal in IJSTR. So Akhilesh, I welcome you. Our HOD is in India, otherwise we would have welcomed you. So I, on the behalf of EC department, welcome you, and we hope we'll have good interaction and we'll have good knowledge. We'll be able to utilize your knowledge fully. So I welcome you.
Thank you, ma'am, very much.
Good morning, Akhilesh.
Good
This is
morning,
Dr.
sir.
Vikas. Let me talk about this MATLAB little bit,
Sure, sir.
then
Sure.
can start. Okay, sir. So
Yes.
as we know that MATLAB is a high performance language for technical computing whose basic data element is an array. Okay, so it allows us to solve many technical problems, especially those with matrix and vector formulation. So we can use MATLAB in many applications, as we know. Okay, like if I say this in the embedded system, okay, we can use MATLAB. Okay, so with the push of one button, MATLAB allows us to generate code and run it on hardware. In other example, you can say in the control system. The control system toolbox of MATLAB that provides algorithms, apps for many types of analysis, designing, and that linear and linear control. And other thing is you can also use in the signal processing. So it allows us to analyze data and see the workflow of development like this. Okay, in the wireless engineering, you can also use MATLAB. Okay, so these are all the applications in which we can use MATLAB, and for research purpose also, the MATLAB is very important. So by those words, I welcome Akhilesh. Please, Akhilesh.
Thank you, sir, very much. Okay. Today we have two sessions actually. First, in the before lunch we have an introduction to MATLAB, that is for beginners. If you, let's say if you don't know about MATLAB, how to code and how GUI work of MATLAB, then we'll discuss about that in this session. And next session, which is after lunch, that is based on the model based design. Basically, we will use Simulink there to design our model, and we will do some kind of testing on user input data also. Okay. So first thing that keep mute your mic during the session. If you have any query or questions, you can write in a chat box. So when this session will end, I will answer that questions. Okay. Okay, myself Akhilesh Kumar, Assistant Manager, Application Engineer for MathWorks Products, and I work for Design Tech. And Mr. M. Jafar, he is a National Manager for MathWorks Products. He is coordinating and is supporting us to organize such kind of sessions also. Mr. Divya Anand, he is a sales manager in your region for MathWorks Products. So if you have any queries related to sales, you can contact Mr. Divya Anand. And Mr. Jitendra Kumar, he is a application engineer for MathWorks Products. So if you have any technical issues or if you want some kind of technical discussions, you can contact Mr. Jitendra Kumar in your region. So first of all, we'll start from applications, that what kind of applications we can design in MATLAB. Okay. Deep learning, as I'm saying, deep learning from MATLAB 2019B. Right now the version release which I use, that is MATLAB 2020A. So lots of enhancements are done on deep learning and machine learning using MATLAB. So a complete model you can design based on the deep learning. Either you want to write the code, or if you don't want to write the code, so both way you can do it by writing. That's why MATLAB is very easy, and MATLAB is very widely used in industries also. If I'm talking about industries, the big companies, like if I'm talking about Indian company, that are Tata, Mahindra. If I'm talking multinational company, I mean some overseas companies like Adobe, Microsoft, they use MATLAB for some kind of applications. Okay. Internet of Things. So a complete MATLAB provides a complete solution for Internet of Things also. So for in IoT, as we know, we require 3 nodes, like the sensor node and internet cloud, where we have to log our data, and deploying model on hardware or doing some kind of analysis. So we have a ThingSpeak as a data aggregator in MATLAB. That is free for students. They can use for their projects and for research purpose also. So complete IoT, let me tell you that IoT is very widely used in industries, and so many industries, they use MATLAB for their digital twin and IoT applications also. Autonomous system, let's say if you have to automate some kind of plant, some kind of devices, the complete solution is available in MATLAB for autonomous system also. You can create some kind of scenes, as you see in this animation. So we have a 3D animation toolbox, and some other toolboxes are available also, like automate. If you are working on driving, then vehicle dynamics toolbox is available. So you can use that kind of toolboxes to create a scenes, and you can test your model as well on that. Automotive, so either you are working on AM kind of vehicle, that is mechanical vehicles, or hybrid vehicles, or electrical vehicles. So we have lots of toolboxes available for automotive designing also. So as I was talking about Mahindra and Tata, they use these toolboxes to design their applications, and for rigorous testing, like software in the loop, hardware in the loop, model in the loop, depends that what kind of applications they have and what kind of testing they want. Robotics, if someone is working on robots, let's say that you are not able to buy expensive robots, right? So what you can do using MATLAB, you can create this kind of 3D robots virtually, and you can connect this virtual robots with ROS, robot operating systems, and you can do analysis, tracking, whatever you want. You can design the complete robots virtually, as well as you can interface real robots also with MATLAB. electromechanical, if you are working on mechatronics or if you are working on renewable energy, depends on you. So we have a semiscape electrical for that, we have a semiscape multi-body toolbox for that. So the good thing is in MATLAB that you can connect one domain with other domain, like we have a semiscape multi-body for 3D mechanical modeling, and we have a semiscape electrical to design electrical devices, like motor if you want to design, or machines if you want to design. So that libraries are already ready-made, libraries are available in MATLAB. Just provide your parameters value, connect that, and test that. So complete electromechanical, if someone is working on mechatronics, so very easily you can access MATLAB to design that kind of applications also. Aeronautics, so any kind of dynamics of aeronautics, if you want to do analysis, so again here also you can create scenes, animations, and you can test it at what is the delay, and what is the 3-2F testing, what is 6-2F testing. So that kind of testings also, and complete aeronautics also you can design in MATLAB. These are some applications which we discuss. And first we will start from the brief of history, that how MATLAB started, and from in which year and when it was launched commercially also. Okay, so the first version of MATLAB was a series of research papers. A person, his name is J.S. Wilkinson, and his 18 colleagues, they published the first research papers on MATLAB. So MATLAB started from that research paper by J.H. Wilkinson and his 18 colleagues. Further, they published MATLAB as a IcePack and LeanPack, but it was a failure. The reason of failure was that they showed just an application, not a documentation. They didn't have a documentation. That's why it was a big failure, that you are just showing the application as IcePack and LeanPack. Later, Mr. Kleemuller, who is a co-founder of MATLAB as well, first application he created, that was called MATLAB. So from Matrix laboratory, Mat is taken from Matrix and Lab is taken from laboratory. So let me tell you, this was just as a calculator for Matrix only. Okay, so this was the first MATLAB based app, and complete MATLAB, you may say that, as a matrix calculator. It was not a only not a programming language. They used the Fortran programming language to create this interactive matrix calculator. So the programming language looks like this, which they used to create this first matrix calculator. First PC MATLAB was launched in 1984 at the IEEE conference, so in the Las Vegas. This was the first MATLAB which was launched for PC, either you are using Mac, Linux or Windows. Commercially, MATLAB was launched in 1985. That was the first MATLAB which was introduced in the world commercially. That is 1985 they launched. Okay, so some stories behind the logo, that how they use this kind of logo. So first logo which you see here, this was the first logo, and this logo was based on the Stanford thesis that was based on the L-shaped membrane. So they published that thesis, they used that logo for MATLAB, and later on the logo was changed like this. 1994 the logo looks like this, and 1910 it was looked like this, 1992 it was looked like this, then 94, 1997. So whatever the logo which you see in 1997, still MathWorks has the same logo which we see everywhere. Yeah. This is our agenda for today. We will see introduction to MATLAB. One demo I will show you, that is fuel economy analysis. So in this case, we have various Excel files, and from that we are going to extract the data, import data in MATLAB, like vehicle's horsepower, like vehicle mileage, or if vehicle is driving in the city or on the highway. Based on that, we are going to create a forecasting model that if my vehicle horsepower is this, and if it is driving in the city or on the highway, then what will be a mileage of my vehicle. Further, in this during this we will see introduction to MATLAB environment, building analytics routines, creating documentation. Like if you want to share your codes, algorithms or outputs, then in a single click how you can create different kind of documentations like doc file, HTML file, or you may say PDF file. Okay. Further, if you want to share your algorithm as a MATLAB application, then how we can create a standalone applications as a .exe file as well. Also, I will give you a flavor of that. If you have to create a website apps like Java library and some other libraries, how you can create that library and how you can interface on website also. Okay. So what is MATLAB first of all? So already sir discussed with you that what is MATLAB. I will just take 1 or 2 minutes to describe it again. MATLAB is a high level language. Why high level language? Means user friendly. Like the mathematical equation which you write in your notebook, as it is you have to write in a MATLAB. Also MATLAB speaks with you. If you have errors in any line, MATLAB will let you know that there is the error, kindly change that. Okay. And whenever you type any word or any function, MATLAB gives you suggestions also that if I am typing S, let's say S, if I am typing, so whatever files are available from S like sine or some other files, so it gives notification, I mean suggestions also. That's why I am saying that MATLAB speaks with you as well. So it is a high level language and it is very easy to remember as well, MATLAB. And MATLAB is also an interactive development environment. As I told that if you are getting error, then MATLAB let you know that there is an error or some kind of things. MATLAB is used for numerical computation, data analysis, visualization, algorithm development and deployment. Deployment means like if you are going to create a .exe file, or if you want to deploy your algorithm in any kind of hardware. So both you can do from the start to end, means start your algorithm and create a real-time applications for you. Apart from that, thousands of hardwares you can interface. More than 130 vendors hardwares are supported with MATLAB. Either you are working on low-cost hardware, either you are working on expensive hardwares like ARM, FPGA boards. So you don't require to know embedded code. We have coders. What coder does? It generates codes and it deploys in your hardware that codes. So this is a MathWorks product family which you see here. So right now there are more than 100 toolboxes available in MATLAB. Okay, so you see that two colors you see, that is blue and one is another is orange, right? So the blue which you see, the toolboxes which is supported with MATLAB. First of all, that any toolbox if you want to access, it works on the top of MATLAB. Okay, the blue which you see, that is a scripting, means there we write codes. Okay, if you are using Simulink, same model you are using as a user interface, as a graphical way, means you are using blocks, you are connecting blocks. Let's say that I have to just design a simple equation, C is equal to A plus B. So in Simulink I will take some blocks, I will take some blocks, I will connect it. You will see after lunch that how to design that kind of models. Just connect and run it and you will get the output. Same thing if you want to do in as a scripting. So there you have to define A, define B, then C is equal to A plus B and you will get the results. Okay. Simulink is used for model based design also. If you are not aware about model based design, let me know you. So in model based design, basically we do some kind of testings. Let's say that if you have to design a plant, and if you want, before designing a plant you want to do some kind of testing, you can use Simulink for that. So some kind of testing like software in the loop, processor in the loop, hardware in the loop, different kind of testings are available. And when you are happy with that testing, then further you can go for the physical modeling of your plants. Okay, these are some applications available. So I will not take so much time here because 100 toolboxes are there, so it will consume a lot of time. So control system toolbox, someone is working on control system, so complete control system you can design. Someone is working on wireless sensor, someone is working on communications, someone is working on massive MIMO, someone is working on 4G communication, someone is working on 5th generation of mobile communication devices. So for that, signal processing communication group is available in MATLAB. Someone is working on vision application, someone is working on image processing, someone wants to work for live tracking, someone wants to work for surveillance purpose. So for that we have a group of image processing and computer vision toolbox. Someone want to interface acquisition hardware, someone want to interface CRO kind of hardware. So for that also we have a test and measurement group. So if someone is from financial background, someone is doing MBA based on financial or on different financial kind of data, so we have a group for computational finance also. If someone is working on biological data, so we have special 2 toolboxes for that, that is Simscape Biology and Bioinformatics toolbox. So either you are going for a drugs designing, or either you are going to do biological data analysis like sequence of RNA and DNA, you can use both toolboxes for that. So as I know, whatever you can imagine, imagine means whatever you think that is it possible in MATLAB or not, you can do it, especially for engineers and scientists. So MATLAB is a language of engineers and scientists. So either you are data scientist or either you are control system scientist, depends on you that what kind of. So you can complete things, you can design it, and you can design very easily also. This is a technical computing workflow of MATLAB, how MATLAB actually works on data. Okay, so first of all, we require to access some kind of data, some kind of inputs in MATLAB, right? So for that, different kind of files are supported with MATLAB. It can be Excel file, it can be PDF, it can be doc file, it can be scientific data, it can be satellite data. Any kind of file formats are supported with MATLAB. You can access through other softwares also, like if you want to interface C language, if you want to interface Python with MATLAB, or some any other kind of languages, that also you can access in MATLAB. Or if you are working on live data, so you can interface hardwares with sensors and you can log that data in MATLAB, and further you can design algorithms for your data. Okay, after accessing, when we got the data in MATLAB, then what is the next process which we are going to do? So in that case, whatever data you will have, that will be a raw data, right? So you require to do some kind of analysis on raw data. Like if you have noisy data, then you are going to design a filter for that to remove noise. So already in MATLAB, ready-made filters are available, just like low pass filter, high pass filter. Just what you have to do there, you have to provide the parameters of filters and create the filters and apply on raw data. Maybe in your data there can be spikes there, or if you want to smooth your data, so that kind of analysis you can do in a single line, or if you don't want to write a code, without writing a code also you can do. I will show you how to smooth your data without writing a single code. Okay, when your data is ready, then we develop our algorithms. So algorithms can be anything. Let's say that I want to design a motion detection using cameras. So write your algorithms, design your algorithm, and develop an application also if you want to share as a standalone applications. So in this session I will show you that how to design an application and how to create a .exe file as well. Okay, after designing the applications, further if you want to share with your colleagues, you can create PDF file, doc file, HTML file, or you can deploy in hardwares also. Further, if you want to interface with other languages like C, C++, Java, .NET, .com, so you can generate libraries also for that. So for that, in MATLAB there is a MATLAB compiler SDK, and to generate a .exe file there is a MATLAB compiler. So in both cases you don't require to know these other languages. We have an app, click, in a single click you can generate that kind of applications and that kind of libraries for different other languages. Okay. So all this process are bi-directional, and all this whatever I talked right now you can do in MATLAB. Okay, this is a demo which I am going to show you, and during this demo you will aware about that how to access the MATLAB also. So we are going to study the relationship between fuel economy. Okay, that already I told we have a horsepower data, we have a mileage data, some other data are also there. So we are going to do analysis on horsepower and mileage data in a different way. Approaches which we are going to do, that is data access data from Excel file, interactively how we can visualize our data, how we can explore trends, different kind of trends. Then we are going to create a predictive model, and further documentation also we are going to do. Okay, so this process we are going to follow: accessing the file, doing some kind of pre-processing, analysis, creating apps, and further share. Okay, so I'm going to switch in MATLAB here. So this is a MATLAB command window here which you see this. So let's say if I define some vectors here, A is equal to 1 colon 10. So in command window you can execute any functions, any files, any variables. Same if I use semicolon, it will be executed but it will be not shown, it will be not displayed. So to suppress any variable, just use the semicolon address. So command window is used to visualize your data and to execute any functions or files. Now you see that when I define this A, automatically it appeared here. So that is called the workspace. Okay, this is the workspace. When you define any variable or any variable is executed, as a default it will be saved in a workspace. Not only as a default, always. Okay, this is the current folder of MATLAB. So you can say current directory also. So if you want to execute any file or if you want to save any file, as a default it will be saved in a current folder. Or you can give a path that where are you going to save and from where are you going to execute it. Okay, there are some tabs. Let me discuss with some tabs that what are the use of these tabs. This new script file is used to write your codes or to create a function file. In MATLAB there are inbuilt functions, and if you want to design your functions you can use this script file or live script. Live script is new feature, so whatever analysis I will do today, I will show you live script. In live script you can visualize your output, figures, everything in a same script file. Okay, these are some new tabs like if you want to open a script, live script, or if you want to create an app, then you have to open this. Okay, and further if you want to search any files, you can open from here any files. If you want to compare two different script files step by step, line by line, then you can click on the compare and provide the path of both files or folders. So it will compare all script file whatever it is available in first folder and in second folder, and here you can provide a comparison tab, that what kind of comparison do you want. Okay, this is used for search files. Okay, this is for import data. We will start from this tab, import data. If you want to save all variables as a .mat file and later you want to use it, so what we can do, we can click on this and we can save all variables which are available here. Let's say that I am going to save it as a my demo data, and if I click on this, here .mat file will be created. Somewhere here it will be created. Let me search it where here you see. Okay, so right now if I define a value is executed. Now let me give a clear command. By clear command you can just wait a minute. By clear command you can clear all variables. Okay, so I am giving clear. Now you see that I don't have here any variable, and if I type a, it will tell me undefined. So MATLAB tells that a is undefined. Now further my all variables are saved here. Okay, just wait a minute. Okay, now if I have to load that all variables, just load my demo, and I will use the tab. I don't have to write everything. So by this name, whatever files are available, it will give me a option. So my file is mydemodata.mat. When I load this, you can see all variables will be here. And further, whatever you are typing in command window, if you want to save it as a diary, just simply give a diary on. If I give this command, a diary will be created here. See, now whatever I will type here as a default, it will be saved here in this diary. Okay. Okay, now more here. There is a favorite command. You can create shortcuts like I created. Let's say that I want to go in MBD directory. You see that directory is changed. I want to go in MLNeo, so you see that directory is changed. So you can create a shortcut from here, just new favorite, and write the codes whatever you want and save it, and when you click on that, that code will be executed. Okay. This is for analyzing the code. This is for run and time. So when you click on this, it will let you know that each and every functions, how much time it is taking, how much time each and every function is taking. So you can use run and time for that. If any function is taking long time, so you will be aware about that and you can replace with other functions, right? This is for clear command, same CLC and clear command which I gave just now. This is for Simulink modeling. So we are going to discuss after lunch, right? So this is for the layout. Let's say that I want to change this layout, just 3 columns, my layout is changed. Depends on you if you want to change your layout or not. Okay. If you have any issues, just do as a default, and you will have a default layout of it. This is the preferences. So like what will be your font size, and if you what do you want to do with the Simulink. And if you want to change some font size, you can change from here. And someone has a proxy server, and if you want to access internet in MATLAB, provide your proxy servers here. So these are the options of MATLAB. Okay, this is a safe path. So let's say that you have any folder which is not in the MATLAB directory, so you can add it in a MATLAB directory, and whatever files are available in that directory, you can access directly. Okay. This is a parallel computing toolbox. This is this is included in parallel computing. So if you want to iterate your iterations on all the cores which are available on your machine, you can use parallel computing toolbox. Or if you are working on deep learning and you want to share your data and iterations on GPU, in that case also you can use parallel computing toolbox. In GPU, as we know, there are thousands of cores. Of course, if you have independent iterations, if you iterate it, you will save a lots of time, right? These are add-ons. So add-ons are used to install some kind of support packages, some kind of other applications which are designed by users. Okay, let's say that I want to interface some kind of hardware in MATLAB. Just I will click get hardware support packages. So any hardware, if you want to access in MATLAB, you have to install the support packages for that, and that support packages are free if you have a licensed version of MATLAB. Okay, so this kind of window will be opened here, and in this window you can search what hardware are you going to install. Let's say I want to interface Raspberry Pi. So I will type just Raspberry, and it will give me an option of Raspberry only. So see MATLAB support package for Raspberry Pi, and if you want to use Raspberry Pi in Simulink, you can use this. So depends on you. Okay. These are helps. Okay, I am going to click on the help. Let's say that how to get a help in MATLAB, how to know how many functions are available in each and every toolbox in MATLAB. So here you see that all toolboxes are divided as a group wise. If I am working in this group, and let's say I am working in deep learning, I have some kind of applications for that I require a deep learning, and I want to know how many functions are available in deep learning. Just I will click on this deep learning. And one thing more, if you are a beginner, if you don't know anything about deep learning or any toolbox, every toolbox has a get started. Just click on get started and complete all this, and you will be a expert in that toolboxes. Okay, this is the way that if you are a beginner, how you are going to learn. Second thing, as I told, how many functions are available in deep learning. Just I will click here functions, it will display me all functions. So like if I am working deep learning with images, I can use these functions. Let's say I am going to click on ResNet 50, and here you see that explanations are given about ResNet 50. Example is also given, and references are also given from where this ResNet 50 has been taken. Okay, so for every function we have a proper documentation in MATLAB. That's why MATLAB is easy. Let's say if you are using other language, and I was working, let's say, on deep learning, and I forgot that how the function name. So very easily you can find out here. But if you are working on other languages, if you forgot that function name, how you are going to search that? Again, you have to start from the beginning. You are going on Google and searching, right? Or if I know the function, what input arguments I can give and how I can give. If I forgot that, if I am using other languages, so that will be a time taking, that you have to search somewhere else, and then you are getting that. But in MATLAB, you don't have to do anything. Just click on the function, search your function, click on that, and check that how it works, right? So this was about the first way how to get the help. Two things are in MATLAB. Two things are very important. What you can do in MATLAB and how to get a help in MATLAB. Okay. And you see that if you click on examples, there are various examples. Thousands of examples are given there for your references. So you can go on this example, you can check this how it works. Okay. Another way to get a help in MATLAB is by giving a command doc file. Let's say I don't know how board plot works, and if I know the function is BODE board, so simply I will give the command doc space board, a proper document will be opened for that. See here, and you see that here so many examples are given, and below algorithm will be given, means the mathematical equation, what are the input arguments, and if I go more below, this is the algorithm. So if you are using any algorithm, you will get the mathematical equations, and you will get some examples also, right? And the good way to get a help, that is the third one which I am telling you how to get a help. Just click on this FX. So here you can search any kind of things. So let's say that I have to find out the correlation between images or data, and I am confused that what kind of correlation will be for between two images and what kind of correlation I have to use for two data. So just here type CORR, just few alphabets you have to type, and here you see two correlations options are there. So this correlation link for rank correlation. So of course this correlation is used for data X and Y, you see. And if I am working on image processing, then I will use this correlation. And if I click on this help, a proper document will be opened for that again. See, same document, right? So like this way you can search any kind of things, and you can identify what kind of functions are available which you want. If I click on this browser, it will be open as a doc file. Okay, fine. Now let me show you the data which I have, on which I am going to work. Fine. I have vehicles data from 2000 to 2012. Okay, let me open a Excel file from here. Just I am going to open outside the MATLAB. So this data we have right now, we are going to access this data in MATLAB, and we are going to do some kind of analysis on this. Okay, like I have car truck, means it is either it is a car or it is a truck. Then rated horsepower is given for that. Further, if a car is driving in a city, or if a truck is driving in a city or highway. Okay, and further this column is for the mileage. Now again question is there that if I have to import any data and I don't know what will be a function for that, right? So what in that case what we can do, just we have to click import data, okay, search your file like I am searching here, and let's say that I am going to use this. Just I will click on this, a new window will be opened. You see that this is a MATLAB window and all data which were available there in Excel file, you can visualize it here. Okay. Now further the next step is range. Here you can define from where to where are you going to load your data. And further output type, are you going to load data as a table? So table is recommended. Why table is recommended? This column names which you see, if you choose the table, then you will get these names also. So you will be aware that in a specific column what kind of variables are. Okay. If you choose column vectors, let's say I am choosing column vectors, what will happen? I will get all the columns as a vector. You see? Okay. So if you have to save these variables in MATLAB in different vectors, what is vector? Single row or single column is called vector in MATLAB, or if you have a single value in your matrix, that is called a scalar. There are some other options also like numeric matrix. So what is the problem in numeric matrix? In this case you see that this data are as a categorical, right? If you choose numeric matrix, it will be a unidentified data, not a number. That is not a number. So this data will be missing if you choose numeric matrix. So in numeric matrix, you are going to select when you want to load only numeric data. Okay. String array, anything in MATLAB, always remember, if you have to write a character, so you are going to write in a single inverted comma or double inverted comma. So if I choose this, all will be imported in MATLAB as a string or character. Cell array is cell index based. So here anything which you write in a curly bracket, it will be imported as a cell. So let's say that I am going to import as a cell, and this is my file name. Oh, let me check what is the file name. That is that one. Okay. Sorry, just wait a minute. So you see that this data are as a cell. If I do who's that one, what it shows here, what is the size of that cell, how many bytes it is taking to store, and what is the class that is cell. And that is also very important, that are you going to load data as a matrix or as a table, and when you are going to load as a matrix and table, that is also very important here. So let me show you. If I am defining a is equal to 34, okay, and if I do whose a, you see that it is taking 8 bytes, right? Now if I define a is equal to 34 and 45, now you see, if I do whose a, it shows 16 bytes. To assign data as a numeric array, it takes 8 bytes for a single value. Same thing if I am assigning as a cell. See here, b is equal to cell of this a. So you see here, if I do whose b, it's taking 12,240 bytes. Just wait a minute. You saw? So how many bytes it's taking, right? So if you have a numeric data, better go for the numeric matrix. Why? To reduce the memory. And second thing, if you want to know that how much memory is available for your data, just give a command memory here. You will get the memory. Here you see that maximum possible array which you can create 6.6 GB or 6681 MB. Memory available for all arrays this much. Memory right now used by MATLAB this much, and physical memory is showing that is the RAM of your machine. So if your system is slow while executing the algorithms, it means you have a low RAM. If your RAM is full, you will get an error out of memory. So these things you have to remember, these basic things. Okay, let me switch here again. I am going to load this data as a table. Fine. Now I have here data as a table, and if I click on this table, I will get all variables in a MATLAB like this. The first year, then second is this, third is different kind of variables I have in a table. Now let's say I want to plot mileage with respect to rated horsepower. So very simple, simply give a plot. Okay, my table name is dat1 dat1 dot rated horsepower, that will be on x-axis, and I am going to plot mileage with respect to rated horsepower, mileage. Now I will get the plot. So it looks like this, some zigzag kind of things, right? Okay, this is a plot of mileage with respect to rated horsepower. Now the question is that I don't want this default graph. I want to make this x-axis, y-axis bold, and I want to change this data also as a different marker. So in that case, what you can do, go in view, click on plot editor, click on property inspector also. Now you see, if I have to make this axis as a bold, I will click bold, it will be bold, right? Now I want to change these colors and markers. Let me double click on this. Just 1 minute. Okay, let me close all this first of all, and just 1 minute. Okay, here I have this, and I am going to click this property inspector, and I want to change this in a different color. Let's say I want as a green color. So now you see this is green. So what I am going to show you, how you can do some kind of modifications as you want, and you can generate a code for that, and you can use that generated code for different kind of data also with same configurations of figure. Also, I want to change this line style. I don't want this line style, I want this kind of line style. So you see that these line styles are changed, right? Line width, I want to increase line width as a 2. You see that is more bold right now. Marker also I want to give, as I was discussing, I want as a asterisk marker, and this will be as like this. So this is, you see that these are the asterisk markers you are getting on the top wherever your data is there. So data is actually big, that's why it looks like this. After doing this kind of modifications, let's say you are happy with that, and further if you want to write something on x-axis, so let's say this x-axis data is horsepower, and further if you want to write something on y-axis, just select this, and let's say it is mileage. Okay, so of course it is a mileage. Now next what we can do, we can generate a code for that. Now this code is generated as a user defined function. So you see that if you are creating your function, just write a function. This is your function name and input arguments in a in a parenthesis bracket. So any function if you want to execute, you have to use always parenthesis bracket. Okay, now I am going to save this, and always remember, when you are creating function, you have to save this function file with the same function name. So here I am using the same function name. Fine, and I am going to close this, and I am going to use that code which I created. So that is okay. Let me check that from which name actually I saved. I forgot actually. just wait a minute, create figure 1. Okay, create figure 1. And now you see I have this code which I generated, and when I run this, always it will show me a same configurations which I did, right? I am not using the plot command, now I am using that function which I created. So like this you can modify your figures, and further if you want to save your figure, there is an option save as, and there are different formats how you are going to save it. Okay, next thing what I am going to do, I want to see a relationship of mileage with respect to rated horsepower based on the truck and car. Based on the truck and car. So there is a function in MATLAB, gscatter. I am going to use the tab. I am not going to write the complete function name, and if I press the tab, automatically it will write for me. Gscatter, and I am going to use this. Okay, now with respect how I am going to group this. So here I will provide the grouping name, data1 dot based on the car truck data. We had one column for the car and truck, and when I run this, see the red one which you see, that is showing mileage with respect to horsepower for car. This color light blue which you see, that is a mileage with respect to horsepower truck. So like this you can identify that mileage is high of car, mileage is higher of car, or mileage higher of truck. So means you can do a graphical way, grouping as a graphical way you can do in this case, grouping as a graphical way, you see. So you see that car mileage is higher, some are going here, and truck mileage is lower, right? So in my case I have a car truck data, in your case you will have a different kind of data also. Now next what I am going to do, I am going to find out the mean value of mileage with respect to car and truck data. So and data which I have as a table, right? And I don't know that how to write an algorithm for that first of all, and I am not going to use any kind of for loop or any other kind of loop. So for that you can use simply var fun, and here you can write your function using function handle. What do you want to do? Type the at the rate and type mean value, okay, and table name, that is data1. Now input variable. Okay, so input variable in my case it is, I want a mean value of date1 dot horsepower. You see that here I am not typing the complete name. If I don't remember, just I will use the tab command for that. Okay, that is rated horsepower. Just wait a minute. Rated horsepower. Now grouping, how I am going to group it. So here I will provide the group name, that is car truck, this one. Sorry, here I have to give the group variable names, group variable name, and what is the group, that is car. Just wait a minute. Okay, just wait, I will use this, and I will use this group name. Okay, just wait a minute. That is car truck, and bracket close. So when I run this, you see what I did. I want a mean value of this variable based on the group car truck. So you see here, for car total number of samples are this much, and what is the mean value of that rated horsepower. Truck total number of samples are this much, and what is the average value of horsepower. So see here I didn't extract it, in a single line I did everything. I didn't use for loop, I didn't extract it, the variables manually, and everything I did in a single line. Second thing, I use this tab to load this data as a table, right? And further, for our automation purpose, we can generate a function file code for that as well. And now you see here again I got a function name, and here I have to provide the file name. When I run this function, that file will be imported again in MATLAB. So for this also you can generate a code also how to import your data. And here everything is given. How many number of columns are there? That is number of variables. And you see that what variables names are available there, right? And to read data as a table, just we use read table. Next step is, let me close all this. I am going to plot this mileage, okay, and I want to smooth this data. Again, I don't know that what is, I am a beginner, I don't know how to smooth this data, but I know about live script. So how to smooth this data? So what I am going to do here, I will click on live script, okay. Different kind of tasks you can do using this. So here what I am going to do, I am going in insert, and here you have a different kind of tasks options. Like if you have to clean missing data or fill missing data, you can go for this. If you want to remove some kind of trends, you can go for this. In my case, I have to smooth this data. How easily we can do without writing a code, right? So here I have to select the table. I selected table, and what variable I am going to smooth, that is rated horsepower. And here I have options to smooth that data, what kind of functions I am going to use. Let's say I am going to use this, and here I am going to increase the smoothing factor also. So you see here in the right side you can see the graph. So here you see the dark blue which you see, that is smooth one, and light blue which you see, that is the original. And after smoothing this, I got output as a smooth data. And further, if you want to modify this data, just click on this and convert tasks to editable code. See? And here you can modify it. One thing more, if you want to make it as a local function, just select this, right click, and here you have an option convert to local function. What it will do? It will create a local function, and when I run, and local function name is this, you can modify also. And when I click here, when I run this local function, same thing will be executed again. So it is giving the error because I didn't load that data. So no matter. So you have to provide that data also in that case. Okay. Second thing, let me do a Control Z again. If I want to create a different function in a different file, just click here, convert to function. And what is the benefit of doing this? Let's say that my demo 1.2. What it will do? It will create a function file for me. See, a function file is created for that. What is the benefit of doing this? The benefit is that I can test, I can check my data, and further, if I am happy with it, I can create a function, and I can call that function in many iterations or in other function files also, right? Now you see how to debug your data also. Let's say that I am getting issues on some lines. So in that case, just I will click here. Let's say I clicked here on 6. Fine. And let me clear all output first of all. 6. Now here if I go, if I run this, it will hold on this line till CL of it is executed, and it is holded here 6. Then you have an option to run this step by step. Next step, so this plot will be executed and I will get the plot. So step by step you can debug your data also. Fine. Okay, I am going to close this. Now I am going to switch on data, the analysis which we have to do right now. So I am going to switch on fuel economy main analysis live script. Okay, so here you see same what I did in my case. I created a function and I am using that function to import that data of 2007. Now I want a summary of that table. If you give a command summary,
summary of this car data simply like this. It will give you a summary that what is the mean value, median value and max value of every variables. Okay, so same thing here. I want a summary of rated horsepower, mileage and CO2. Just write in a curly bracket your variables like this, and I am going to execute this section only. So here you have an option to break as a section. So if you ran first section, then you don't have to run again. So section wise you can run it. So there is an option here, run this section, select the section and run this section. Next you can click on this blue strip to run that. Okay, so now I am going to plot mileage with respect to rated horsepower. So again you see that the same function previously which I showed you, I created after the modification. So here what I did, I created a function for that. I am providing the two inputs and it will plot for me as I modified. Okay, so see here, just wait a minute. So this is the plot. This is showing the relationship between miles per gallon, means that is the mileage with respect to rated horsepower. So how this graph is modified? Using the plot editor like we did, and we generated a code in previous one. Now some logical operators how you can apply. So first of all, let me tell you, if you have a character data, you can't apply a logical operator. You have to convert as a category. So to convert any character data or string data as a category, just use the command categorical and convert this column as a category and save it at the same place. Okay, so same thing we are doing here. Okay, next what we are doing, I want to extract IDs of car. So here I use the logical operator. If I use car data dot car truck, this is my column name, is equal to car. Wherever this condition will be satisfied, I will get 1, else I will get 0. So just simple, I will show you that how it work actually here. Let's say I have some data here. Fine. And I want values which are equal to which are equal to 2. Okay, so what will I do? IDX is equal to A equal to 2. So wherever this condition will satisfy, I will get value 1, else I will get 0. And what that values are there? A, my original vector, and this logical index, and I will get that value, that is 2 of course, right? Or if in this case I want to find A is greater than and equal to 2. A is greater than and equal to 2. So these are the operators which I am going to apply, and I got wherever A is greater and equal to 2, I got 1, else I got 0. And what that values are there? So same A in bracket IDX, and we will get that all values, right? So same thing here I am doing. I am extracting the ID of cars, then I am extracting the ID of if a car is driving in a city highway, means if car is driving in a city, and if car and truck is driving in a, this is for the actually city highway, and this is for the if there are trucks which are driving. I am extracting the truck data. So here you see that how to apply AND operators also. So in this case I am extracting the city data from this column IDs, and also I want from this column only truck IDs. So like this you can apply. So multiple operators, depends on you that how you are going to apply the logical operators. Now distribution, how your mileage is related to, if a car is driving on the highway and if car is driving in the city, how they are related with each other. You see here, first one is if a car is driving in the city, and second if car is driving on the highway. So here we have data city highway and city fit, highway fit. This data is for car. So you see that if your car is driving in a city, then mileage is higher. if car is driving on the highway, then mileage is lower. This is the normal distribution. So this is the distribution fitting. Now again, here you see, if I open this function, just wait a minute. Open this. So this is the function. How we can write this function? Because you see there are lots of lines available. So I will let you know how to write these functions also. Second thing, there are different kind of fittings. Let's say I am throwing a dice. I want to identify what will be a probability or what will be a chances when I throw a dice, it will come 6. I don't know, right? So that is called the distribution fitting. So same thing here we are doing. That is a random distribution. That is a Gaussian equation simply. Okay. So if I have to do this kind of fittings, what we can do, just see these apps. And that is a part of a maths, stats and optimization. I am going to use this distribution fitting. And let's say I am going to extract data A is equal to date 1, the data which I am going to fit. Let's say that is mileage. Okay, I think it is car data, right? Car data dot rated horsepower. Okay, I have this, and I have this app, and I want to feed that horsepower. So first step is to import data, and data is A, that is horsepower. Okay, so then for the next step is we have to create the fit. So here you see, this is my data right now. Okay, if you have some censoring, if you want to remove some data and all this, that also you can provide. If I click on view, it is showing the histogram of that mileage. Now I want to know, it is a normal distribution or it is a different kind of distribution. That I want to check on this data. So okay, after doing this, I am going to close, and this is my data. I am going to fit this data as a random fitting. Okay, so in this case, there are different distributions. So first I am going to choose normal distribution, and I am going to apply. You see that after fitting as a normal distribution, we got the variance value, we got the mean value of Gaussian equation, and sigma value, and mu, mean and standard deviation also we got. So this is the Gaussian distribution, but I am not happy with that. Let's try some others also. So again I will click new fit, and I am going to choose different. Let's say relay I am going to choose. Okay, and apply and close. You see that we have two kind of fitting. The blue one is relay and red one is Gaussian, but you can see that Gaussian is better than relay, right? So what we can do, next step, manage fit, and I am going to untick, remove this and close. So we have a Gaussian. And how do you want to visualize this data? Right now as a default is a probability distribution function. You can use cumulative also, just select like this. Okay, depends on you. Okay, after fitting this data, if you go here in file, and you can generate the code for that. So same thing here I am doing. I generated a code for two data, I fitted it, and G scatter already we saw. That is a G scatter. If car is driving in a city, that is the mileage with respect to horsepower. Green one, if car is driving on the highway, that green one. So in this case, if car will drive on the highway, then mileage is higher. It is the grouping, right? And now you see this one. If truck is driving in the city, then mileage is very low. If truck is driving on the highway, then mileage is okay. So like this you can differentiate by grouping this data. And this var fun, already we discussed how var fun work. So I am going to take the mean value from this table, input variables rated horsepower and mileage, mean value of rated horsepower and mean value of mileage, by grouping the variables city, highway and car truck. So when I run, I will get some outputs. See, city, if it is in city, if it is driving in city, if it is car is driving, total number of sample this, and the mean value of rated horsepower is this, and mean value of mileage is this. In city, if truck is driving, total number of samples, what is the rated horsepower, and what is the mean value using the var form. Okay. In MATLAB there are different kind of ANOVA to find out the relation between multiple variables. One-way ANOVA, two-way ANOVA, and n-way ANOVA. So you can identify what kind of different ANOVAs are available there. Just simply run this and you will get the properties of ANOVA, output of ANOVA. Further, box plot. So what here I am going to do, I am plotting mileage as a box plot based on the group this. So let me first plot and explain that what is box plot actually. And box plot is very important to identify the outliers. So you see here, I did a box plot of mileage and grouping I did based on the car, truck, and if car, trucks are driving in the city or highway. So you see here, this is the box plot if a car is driving in the city, okay, and this is showing this line, this is the mean value of mileage, and below this 50% samples are there till here 75, and here remaining 25% samples are there, and this plus sign which you see, that are outliers because these data are not coming within this 100%. So these are of course outliers. So same box plot for car, if it is driving on the highway, so you can identify that how many outliers are there. Same for the truck and same for the if truck is driving on the highway. So box plot is used to identify if there are outliers or not. Main work of box plot is this. Now next step is to create a mathematical equation that if I give mileage as an input and I give horsepower as an input, then I have to predict what will be a mileage. Okay, so in this case I have mileage data and I have a rated horsepower. Okay, so to do this, what we can use, let me close this first of all. This is a part of again math stats and optimization. So this is a part of a curve fitting. Now I want to show you how to generate a mathematical equation for your data without writing a single code. So in this case I am going to x-axis will be x data is rated horsepower, and y is mileage. Okay, now I want to create a mathematical equation for that. So here you see different kind of options are there. What kind of equations do you want for your data? Let's say I want a custom equation. If you have a custom equation, write your equation and extract the parameters of a, b, c in this case. So in my case I am going to use polynomial, and I want to center and scale also. So scaling is very important. If your values are big, scale it between -1 to 1. So you will get the robust model in that case. Okay, now you see here I am polynomial of degree 1. Here you see this is my equation, and with 95% confidence bound, these are the range of P1 and P2. That is the regression coefficient. That are regression coefficients. And what is the R square value and root mean square error. So if I am using polynomial of degree 1, root mean square error is 4.004. Sorry. Now I am going to increase this degree. Now you see that root mean square error is decreased. Also R square value is going near to 1. So that is a perfect. Now I am not happy with that. What I can do, I can choose different equations also. From here I can create a duplicate. Just select this, right click and create a duplicate. Open this. Let's say I am going to use Fourier for that. And you see this is the Fourier. Now here you see how you can compare which one is best. So you see here, for polynomial of degree 4, root mean square error is this, and for Fourier that is 3.5. So if you compare, polynomial of degree 4 is better than Fourier, right? Because root mean square error is lesser than that. Even R square value is higher of polynomial, right? So when you are happy with that, just remove this and this is the my graph. And further, there is an axis adjustment. If I click on this, I can check that how my data is going in future. See, right? And further, again, next you can generate a code. If you don't want to generate a code, just select this and save it to workspace. So as a model, it will be saved. Let's say that model name is this. What this is a predictive model. You can use this model to predict. If you give a new horsepower value, it will predict what will be a mileage on that. Okay, I am going to save it, and this is my PP. Now here, if I provide mileage value, horsepower value, let's say 400, and it will tell me what is the mileage, that is 16 miles per gallon. So I created a predictive model as a PP, and I am predicting mileage, right? So here same thing I did here. If I go in this analysis, just wait a minute. Okay, so same I generated a code and I created a custom equation and I fit it for that. So when I run this, it will show you a fitting graph of this. See, created a function providing the input and output, and it is giving me a fitting plot. So same way you can plot for different models also, like this. That case was if car is driving in the city. So here you can create a mileage relationship with horsepower. Like if car is driving in the city, car is driving on the highway, truck is driving in the city, and truck is driving on the highway. If I run this, multiple fittings I will get. Single function I am using for the same for every data, and we got the multiple fits for that. See. Okay, now next is how to create a doc file folder. Whatever I did, I want to share with my colleagues. So how we are going to generate a doc file folder? So first of all, you have two options. If you don't want to show your codes, just click on this. Your code is hidden. Just we have a output only. Just you want to share outputs, let's say, and go save as, export. If you want to export as a Word document, just click export to Word document and give your doc name. My demo, I am giving 1, 2, 3. What it will do, it will create a doc file folder. Fine. See, this is the doc file of output. And further you can use these figures and all to write your thesis, to write your papers, depends on you. You have an option to save as PDF file also, HTML file also, or as a latex file also, depends on you. Okay, this is about the how to create a doc file. Next step is how to create an app. So I can create a .exe file and I can share with others also, right? So I am going to close this. So in this case, let me summarize what we did actually, then I will close. So first of all, we saw that how to export and import data from table. Further, we did some kind of trending analysis, that how horsepower is varying, how mileage is varying, sorry, not horsepower, how mileage is varying with respect to car if it is driving in city or highway, and with respect to truck if it is driving in city and highway. Then further we created a random fitting, that is a distribution fitting, and I show the app that how you can use app to create this kind of fittings. Next, we visualize our data based on the groups using JScatter. Further, we created a mathematical equation using curve fitting app. Okay, and next step is how to create an app for that. I'm going to close everything and I'm going to clear all variables, and by giving CLC command, I'm going to clear this command window as well. Okay, how to create an app? So if I go in home, if I go here new, I just have to open the app. Just wait a minute. And let's say I have to create an app for this Gaussian equation. I am going to create an app for this Gaussian equation, and I will change the standard deviation value. I will change the mean value. Then I want to check what will be effect on my plot. This I am going to do in this case. So, okay, this is the app designer. I'm going to start a blank model. There, here you can see libraries. If you want to plot, you can use axis. If you are working on aerodynamics, you can use these blocks. So in my case, I want to plot. So I am going to choose axis. Okay. So this is axis here, where I am going to plot it. Further, I want a push button. So when I click on this button, my code will be executed. And I want to vary mu value and sigma value. So what I am going to do in this case, I am going to take edit numeric field and one more edit numeric field. So I am going to rename this. I selected this, and from here I can change whatever I want for this time. So this is, let's say, mu, and this one, let's say it is sigma, that is standard deviation. And further, if I want to change the color of it, that also I can do, depends on you. So whatever I will write, it will look like this. I'm just going to make it as a white. And background color, if you want to change, just select any value and background color will be changed. Same if I want to change color for this, and from here you can choose different. So this is the property, that what modification you want. You want to make it bold, just select, it will become a bold. This is the property. This is button, and I want to modify as a click. We have not so much time, so I am not going to show some modification, just simple tab I am going to use. Okay, now we are done. We have mu value, we have sigma value. Okay, and we have this click button, that is a push button. Now I want to write code below the push button, so this code will be executed. So here I am going to create a push button function folder. Okay, so here I have to write the code. So already I created that mathematical equation for using MATLAB. So I am not going to write it again, just I am going to copy paste and I am going to switch here. We have to do little modifications here. This is my x value, which I am converting as a normal distribution using Gaussian equation. I need this sigma value and mu value. So as a default in app, any data will be saved as a .app. So what will be a mu value here? Mu is equal to app dot mu. See, here it is given, so you don't have to search for anyone. Mu edit field, right? Mu edit field, and I am going to take value of it. I got mu value, so whenever I will change the value in that edit text, it will take data from that. Okay, now sigma is equal to app dot sigma edit field dot value. Now we have mu and sigma, and this is my mathematical equation. Okay, in plot we have to do a little change, that where are you going to plot, on which axis we are going to plot. So right now we have only one axis, and the axis name is app dot ui axis. So here just I am going to use app dot ui axis. Here I am going to plot. Now let's check that my code is working fine or not. I will click just run, and it is asking to save it. Let me save it, and I am going to run. Change the folder. Actually it is in different directory when I create it. Okay, now here I will provide some mu value. Let's say it is 0.1, and sigma value, let's say it is 0.5, and I want to check the graph. See, perfect, it is working perfect. Now I am going to change this mu value as of 5, and I want to check how my plot looks like. So this is a Gaussian equation. It looks like when your mean value is 5 and standard deviation is 0.5, right? So now how to create a .exe file for that? Very simple. If I have to create a .exe file, just I have to go and share, and 3 kind of apps I can create: MATLAB app, web app, standalone app, right? So just wait a minute. So MATLAB app, if I select MATLAB app, it will create this kind of apps. If I select web app, it will create me a web app which I can host in my institute with others. So it will create a web app, and I can host it on browser, and I can share link with my colleagues. They can use online. Third is standalone app, that is used to create a .exe file. So I am not going to create it, but you can create in a single line. It will take 10 to 5 minutes to create. Just you have to click on package and it will create a .exe file for you. Here you can provide icons, author names, email, company name, summary, and just click on this package. It will create a .exe file for you. Okay. So like this, we can make different kind of apps. Okay. So here when you create a .exe file, this kind of files you will get it. So this is a .exe file, like this it will be generated, and you can share with anyone. They can run it without MATLAB. Fine. And for this demo which I showed, if you want more advanced app to create, so you can create more advanced as well. So in that case you can use multiple figures window, you can use multiple push buttons, right? So here you can see multiple and check boxes also used, right? So here if you have to, let me run this first of all, and you can select, this is a fitting app actually. So I want to fit data of 2003, not all, and I want to create a fitting for car and trucks both. And car and trucks, if it is driving in city and highway, I can select from here what is the confidence interval and just simply click on plot. And here you can see that status is processing, when processing is done, and this is the fitting plot. So lots of advanced apps you can create. If you have in future any kind of session only based on the apps only, then we can show more advanced apps also. So right now just I showed how to create a basics apps. Okay. Okay, now I am switching on my PPT. So what we saw right till now, we imported data from file, we did some kind of trending analysis, then further we generated an algorithm, we created apps. Also we saw how to create as a HTML, doc file, PDF file, and how to create a standalone apps also for that. Okay. Now further some advanced what you can do with MATLAB and what we saw till now. So file formats for access, it can be Excel file, text file, binary, audio data, video data, images, web services. If you want to use internet clouds to import and export data like this kind of JSON and CSV and image data, JSON is also supported, and any kind of internet clouds, if you want to load data in MATLAB, that is also supported. And further, if you want to access some other languages, so in basic MATLAB you can interface with this kind of languages, .NET.com. Or if you have a hardware, then there is a data acquisition toolbox. If you have a data acquisition hardware, that you can use, or some kind of standalone instruments like CRO instruments kind of stuff, there you can also interface with MATLAB. And further for data analysis, you can do pre-processing. We saw how to do some other kind of analysis, and if you want some advanced analysis, that also you can do it, because there are many toolboxes for designing filter. DSP system toolbox is there for transmitting data from one end to another end. For that we require to create channels, so we have a communications toolbox, 5G toolbox, LTE toolbox. Visualization we saw as a 2D plot, scatter plot, G-scatter plot, 3D plots also you can do, surface plot also you can do, depends on you, this kind of plots you can do it. And further some, as I told, some advanced add-on tools are available. If you want to do optimization or control system designing, signal processing or communications, image processing or computer vision or parallel computing, you can go for that. Additional product means if you have some additional toolbox, that also you can interface with that. And sharing, you can share, we saw right how to create a report. If you want to create a advanced report, there is a MATLAB report generator tool. So let's say if you want to generate a PPT or some different kind of modifications, more advanced, you can go for MATLAB report generator. You can package it as an app also, and you can deploy your applications on other environments like Java or C++, depends on you. So we saw also how to create MATLAB apps. So interactively you can create apps, and interactive applications you can create to perform, and you can add it in your MATLAB. You can add display in your gallery, like which I showed you, and include in so many products are supported to create MATLAB apps. Doesn't matter what toolboxes are you going to use, or you can package your own apps as a .exe file for that. So further the process what we learned here. So we require, for analysis we require MATLAB and the toolboxes, create applications for that, and further to create to interface with other languages we require a MATLAB compiler for standalone applications, for Excel add-ins, and for Hadoop. We MATLAB compiler toolbox you require for that. Okay, and end user will be required, that is a MATLAB compiler runtime that is free. Like if you run Java program, you require a Java runtime. To run C you require a C compiler. Same end user will be required MATLAB runtime, free, anyone can download and install. Okay, so this was the session about today. And further, if you are a beginner and if you want to learn MATLAB, okay, we will discuss about this on ramps after lunch. Okay, if you have any questions right now, you can ask me here. If you have any